For generations, the pillars of modern physics have stood like grand monuments, complex, beautiful, and seemingly unshakable. We believed we had deciphered the rules: how galaxies form, how stars ignite, how matter arranges itself amid the turbulence of a universe governed by time, gravity, and space. These were the concepts taught in schools, coded into satellite systems, and used to map the destiny of the cosmos. Then a new eye opened on the universe, and eye so sensitive it could peer into the earliest chapters of existence. And what it found wasn't reassurance, it wasn't expected. It was a revelation so profound, so unmistakably contradictory, that it rattled the very mathematics we've trusted for more than 100 years. What it uncovered wasn't merely odd, it was impossible. A galaxy filled with mature stars, vast and well-formed, appearing in a time when, by all known scientific reasoning, such a structure shouldn't yet exist, and it wasn't an isolated case. Again and again, more such galaxies appeared. With each image, it began to feel as if we were waking up in a cosmos we no longer recognized. These aren't minor glitches. This is a tectonic shift in physics' sudden collapse of what we once believed to be eternal truths, because what's been discovered doesn't merely revise our cosmic understanding, it obliterates it. This instrument wasn't designed to casually observe the sky. It was engineered as a kind of time-traveling lens built to peel back layers of space and to let us glimpse the earliest epochs of reality. When it focused on a patch of space that seemed unremarkable, it detected something unusual, a searing point of light standing out like a beacon in a storm. At first, scientists thought it must be relatively nearby, given its brilliance, but its redshift, the stretching of light from the universe's expansion, told a different story. This object, named CEERS 93316, wasn't close at all. It existed at a redshift of 16.7, just 230 million years after the Big Bang, practically the universe's infancy. Yet what they saw wasn't a cloud of nascent gas and dust. It was a colossal galaxy, fully developed with stars already formed and arranged in intricate patterns. In short, it had evolved. That's like finding a fully grown adult in a cradle. It shouldn't be feasible, but it didn't stop there. As astronomers zoomed in, more of these outliers came into view, entire groups of immense galaxies, shining brightly in ways that defy every model of galactic formation we've ever relied upon. Either the physics governing the early universe is mistaken, or we're witnessing an unknown cosmic mechanism completely outside our current comprehension. Once the initial astonishment faded, researchers turned to measurement. They estimated the mass of these ancient galaxies, calculating how much gas, dust, and invisible matter would have needed to collapse in record time to produce them. The results were astonishing. Some galaxies appeared to have masses comparable to the Milky Way, yet they formed just a few 100 million years after the Big Bang. For reference, the Milky Way took over 13 billion years to take shape. According to prevailing theories, the early universe should have been far too hot and chaotic for such complex structures to exist. Radiation from the Big Bang was still saturating space, making star formation nearly impossible. And yet, we're now looking at galaxies that seem no different from the ones we see today. Some had even depleted their star-making fuel, having burned it in an intense, rapid burst that leaves our models gasping. Worse, they appear in clusters, suggesting not isolated oddities, but a full ecosystem of impossibilities. If the timeline is incorrect, or if we've missed some massive mechanism at play, then we may have to dismantle and rebuild our entire understanding of how the cosmos takes shape. What this telescope is uncovering isn't just new objects, it's the boundaries of what we can perceive. These galaxies lie so far away that they should be hidden beyond what's called the Hubble horizon, the theoretical limit beyond which light hasn't had time to reach us since the universe began. And yet, there they are. This brings forth a troubling paradox. The light from these galaxies shouldn't be visible at all, which can only mean one thing: our grasp of how spacetime expands may be incomplete. As space grows, the Hubble horizon also stretches, revealing more of the universe. But this instrument isn't just catching galaxies drifting into view, it's finding ones that, by all logic, were never supposed to be there. This suggests a faster-than-expected acceleration of cosmic structure formation, or, even more unsettling, that space itself might be curving or behaving in ways our equations can't yet model. It's like trying to see the edge of a canvas that's growing faster than you can follow. What we're observing isn't just ancient, it's unfathomable. And this impossibility is speaking in a language our current science can't yet translate. Symmetry fractured, cause and effect unraveling, models failing. This is no longer just a telescope. It's a confrontation with reality, a mirror being held up to our assumptions, reflecting back something we were never prepared to face, that the rules we've lived by may not apply after all. With each new photo, each confirmed redshift, each unexplained phenomenon, the cracks in our theories widen. The Big Bang model, once the unshakable foundation of modern cosmology, begins to resemble a patchwork cobbled together more from convenience than truth. In response, scientists are proposing alternate frameworks: cyclic universes, emergent spacetime, quantum cosmogenesis. Some suggest we're seeing echoes from a previous cosmos overlapping with our own. Others argue we're misinterpreting time itself, that perhaps time didn't begin with the Big Bang, but formed later, emerging from disorder rather than causing it. Some even dare to question the meaning of redshift. What if it's not a measure of distance and age, but something else entirely? Could light behave differently across extreme time frames? Could constants we assumed were fixed actually evolve over time? These ideas have one unifying theme: they dismantle the current model entirely. And yet, they're no longer fringe, because now, with more contradictions than confirmations appearing, the scientific community is being pushed to entertain what once seemed unthinkable: that the Big Bang as we teach it may be, at best, an approximation, or at worst, a beautiful misunderstanding. For years, dark matter has been the invisible structure assumed to hold the universe together, unseen, unfelt, but mathematically necessary. It was believed to account for 85% of all matter, guiding galaxies like an invisible architect. But the image is now arriving challenge that scaffolding. The galaxies being seen ancient, vast, and highly organized would require dark matter densities beyond what our models permit. Some would have had to be so dense they'd collapse into black holes. Others appear where dark matter shouldn't have been thick enough to allow such gravity. This isn't a calculation error. It's a deep contradiction. If dark matter behaved differently in the early universe, or if it's distributed in ways that don't match our predictions, then perhaps it's not what we think it is. Maybe it doesn't exist at all. Maybe what we've been calling dark matter is merely a placeholder for a force we haven't yet discovered. If so, then the structure of the universe may be ruled by laws as foreign to us now as quantum physics was to those before Einstein. One of the most disturbing insights is that time itself might not be consistent. These galaxies don't just seem too large or bright, they seem too old. In some cases, their stars appear older than the universe was when they formed. That's not a warning sign, that's an emergency siren. If time flows differently under certain conditions, extreme density, high energy fields, then everything we understand about cosmic timing may be off. This gives rise to wild but serious theories: variable light speed, altered gravity, or even the notion that time isn't fundamental at all. That it's an illusion born from disorder and perception. Imagine time not as a stream, but a haze, sometimes thick, sometimes swirling, backwards, sometimes still. These galaxies might be glimpses of a universe where time doesn't behave predictably, where cause and effect are tangled, and evolution doesn't follow a straight line. If that's true, our equations aren't outdated, they're written in the wrong script. But the anomalies don't end with galaxies. Some of the stars this telescope has detected resemble the elusive population 3 stars, the first stars theorized to exist. These should be massive, hot, and devoid of heavier elements, forged only from the universe's earliest gases. We've never seen one until now, or at least something eerily close. These stars don't align with any known life cycle. They're too large, too pure, too powerful, and yet they persist. It's as if evolution skipped steps. Some speculate they might be the result of pre-stellar collapses or even near black holes that ignited in ways never imagined. If true, this would challenge how we understand star birth and death and ask a chilling question: are there forms of energy and matter at work here that we don't even have words for yet? And then there's the most disquieting possibility of all. In some of the deepest field images, subtle patterns have emerged. Repeating shapes, symmetries, alignments, and galactic spins stretching across billions of light years. These arrangements defy random chance.